All right, let's look at the probability 2. This is worksheet number 10. How come it doesn't say it here? Properties and conditional probability. So now we learned the probability is the likelihood of an event. We're going to look at some properties of probability and investigate more interesting case where we limit the probability by given groups. So this will help us to compare different groups and see which group is more likely to do certain things or a certain way than another group. All right, so let's get some properties. For any event A, the probability ranges from 0, which is 0%, to 1, which is 100%. This means the probability of any event cannot be negative, because lowest number you can get is 0, so it cannot get negative probability, nor you can get more than 1 or 100%. So there's no such thing as 120% probability. When we talk about percents in the beginning, it is possible to have 120%, 180%, 200%. Depends on what we're talking about, right? So we're talking about like percent increase, percent comparison. It is possible to have more than 100%. But when we are talking about probability, we cannot have something more than 100, anything more than 100%. Let's look at the second property. If probability of A is equal to 0, then A is called an impossible event. This means that A cannot happen, right? Cannot happen, or A is impossible. The other case, when P of A is equal to 1, then A is called a certain event. This means that A happens all the time. All the time, like 100% of the time. So 0 probability 0 means it's not going to happen. Probability 1 is it is going to happen. We know the complement because of the complement event is the opposite of event. Let's say the probability of certain thing happening is 20. Then the complement event has 80% chance. Because for example, if you have 20% chance of winning, that means you have 80% chance of losing, right? So they always add up to 100%. In general, we can calculate probability of A complement by looking at 1 minus probability of A. Like, how do I calculate 80%? It was 100% minus 20%. So I can look at it as a 1 minus probability of A, or if you want to do it in terms of percent, 100% minus probability of A. Either one works. All right, let's look at the next question here, number 1. If there's a 30% chance that it's going to rain tomorrow, what's the probability it's not going to rain? So rain is A. Rain is A. Not rain is going to be A complement. Again, raining, not raining, they're opposite of each other. So if there's a 30% chance of A, that means it's 100 minus 30%. So 100% minus 30%, which is 70%. So probability of A complement is 70%, or of course 0.7 works too. Either way is fine. Okay, I'm going to have you try part B, and let's look at the next concept after part B. Next concept we'll talk about like one of the application of probability. Here we're going to talk about false negative and false positive of a test. I don't know if you guys heard the term before. When testing for a certain virus or disease, ideally, if a person has a virus or disease, then the test comes out as a positive, and let's say COVID-19, I got tested twice. So if I have it, it should come out positive, right? If I don't have it, it should come out negative. That's not the case in reality all the time. A false positive. That's why they use this false language. False positive is when test comes out positive when a person doesn't have the virus. A false negative, so these are like when we get a wrong result. Negative is when the test comes out negative when person actually has the virus. So how is it possible that I have a virus but my result comes out negative, and how is it possible that I have no virus but the test comes out negative, right? So that's why it's called false positive and false negative result. Both cases could be dangerous because it gives you misleading result. but in reality that happens, right? So let's look at the next question here. Suppose 100% are given tests for the certain virus. Answer each question for a given result. So I noticed there's a table, there are different parts to the table. So this column represents person with the virus. This column represents person without the virus. This row represents people who tested positive and negative, right? So when I add up all these numbers, that'll be 100. So before I get started, just to kind of organize it a little better, I'm going to look at people who have the virus. So there's 83, 8, so that'll be 91. There are total 91 people who had the virus. And then there are 9 people total who do not have the virus, right? Right here. Maybe these are all patients with symptoms or whatever. Now I'm going to look at the columns. Person tests positive. So these two, they're people who tested positive from the testing. So that's 85. And then there are 15. So my grand total of 100. So out of 100 people, these are the breakdown. So let's look at the first question. Part A, probability that somebody has virus. Okay, I'm looking at the virus. There are 81 people total who has a virus out of 100. So my answer will be 81 out of 100. Again, this is probability. My sample space is 100. I'm looking at people with the virus. They're 91. Let's look at the second one. Probability that somebody tested positive. Again, it's going to be out of 100. How many people have positive? We're talking about this row. There are 85 people, so there'll be 85 over 100. Third question, virus and positive. So this is intersection and. This is a group of people who have virus and they also have to test positive. So we're looking at specifically this virus, this positive, where's the intersection? Intersection is a common part. So those 83 people only. So that's 83 over 100. The next one is virus or positive, which is the union. This means including people who have virus or people who tested positive. So it's going to be a bigger group. So people who tested positive, people who has a virus. So when you take the union, it includes these 3 groups all together. So how do I calculate that? So that'll be 83 plus 2 plus 8 over 100. So that'll be 93 over 100. All right, and then next question is probably the virus complement. So people who do not have virus. So this is people, that's my virus. Complement is that. So that'd be 9 over 100. So it'll be 9 over 100. I could have also looked at probability the virus is 91 over 100. So I could have just gone 1 minus that. It'll give you this answer. All right, let's look at the next question. It's going to be a little bit more involved. This is probably a more interesting question. It says, suppose that someone who doesn't have virus is selected. What is the probability that this person tested positive, right? So let's say I didn't have a virus. I go get tested. There's a slight chance that I actually get tested positive, which is not good, but that's possibility. So this is like where it says we're looking at people who don't have a virus is selected. So now we're limiting our group. So this is what's different. Here, limiting our group to the people who do not have virus. So that's going to be our sample space. So when I see this, it's like, oh, it looks like this is a new sample space. And then it says, what is the probability that this person tested positive? So basically what we're doing is, just look at the people who do not have a virus. So out of these, what's the probability that this person tests positive? Oh, there are 2 people right here, right? So my answer is 2 out of 9. Notice that it's not out of 100, it's 9 out of 10, because here I'm looking at only people who do not have virus, no virus. That's why it's going to be 9. All right. So this is, let's look at the next one, kind of similar. Suppose that someone who has the virus is selected. Okay, so now you're looking at only this group. Again, just because they say that, my new sample space is going to be new sample space. It's going to be 91. Because the question says someone who has the virus is selected, that means just look at this group. And then from there, we look at the probability that person tests negative. So out of those group, only 8. So 8 out of 91. Okay. So what is the probability of false positive for the test? Again, false positive means you don't have the virus, but somehow you got tested positive, which is basically what we answered in part F. That's exactly what part F was. So what's the probability of a false positive? It'd be 2 over 9. So part F and part G are actually, part F and part H are basically the same question. How about the next question? What is the probability of false negative for this test? Again, false negative means you have the virus, but when you get tested, you got negative. So that was false result, right? That's exactly what part G was saying, right? So this one is the same. So that'll be 8 out of 91. So these two questions are just a repeat of these questions, but in real life, a lot of people will say false positive, false negative. But mathematically, how do I calculate that? I have to convert that into this question and this question, right? All right, I'm gonna have you try to answer number 3, and I'll meet back at the next part. So the probability we calculated for the false positive and false negative is an example of this thing called conditional probability. So the probability of A given B, so I'm going to highlight this given part, is the conditional probability denoted by P. You just notice that little bar, B. B is the extra information that is provided. So the extra information could be in, given that somebody has no virus, or given that somebody has the virus, then what's the probability of this and this and this? So that's the extra information that's given to us. It's called conditional probability. In terms of a symbol, we do A, and then little bar thing here, and B. B is the extra information. So these are two possible ways you can interpret this. They're kind of same, but the probability of A occurring given or provided, assuming that B has already occurred. Another interpretation is the probability of selecting A out of B. So in both cases, the sample space will be B. The original sample space S is no longer the sample space, and we have the new sample space. That's why if I kind of go back to the previous questions, like this question and this question, they didn't have 100 on the bottom because 100 was the original sample space. Once they say, just pick a person from here, or given this person has a virus, then your sample space changes. All right, let's go back here. All right, 2 different ways to calculate conditional probability. P A given B. When I write it, I'm going to read P, probability of A given B. This is how I'm going to read it. So P A given B is probability of B goes to the, again, B is the new sample space, so I'm going to put the B on the top, and then probability of A and B. Another way to look at it is basically you count how many things are in B. So count how many things are in B, cardinality of B, and then count how many things are in A. Out of B, right? Out of B. So let's look at the next question here. Use the same table from the previous question and answer each question. So probability of positive given virus. Again, the second part is the given part. That means that's going to be your sample space. The virus was, let me just rewrite this, 91, 9, 85, 15, grand total of 100. So let's go back here. Probability of positive given virus. Again, virus is the sample space, new sample space. There are 91. And out of those, how many people tested positive? 83. So I'm going to write that. That's my answer. The second one, again, conditional probability of positive given no virus. Okay, I see no virus is the second part. There's no virus here. Oops, no virus. That means you're talking about these 9 people as a new sample space. Out of those, how many people test positive? 2. So 2 out of 9. Okay, let's do the next question. It says probability of negative given virus. Okay, so again, virus is the new sample space, so that's 91. And out of those, how many people tested negative? That's 8. And then the last question, probability of negative given no virus. All right, fine. No virus is again my sample space, and then negative 7. There we go. Okay, from the previous questions, which probability indicates the false positive rate and which indicates the false negative rate? Again, false positive means you don't have a virus, but somehow you got tested positive. So no virus is given and you have to get tested positive. So this one, part B. So part B. Which indicates false negative. So false negative means you do have a virus, but your result was negative. That's why it's called false negative. So you do have a virus, that means it's given virus, that's the second part, and you have to test negative, so part C. The next few questions are very similar, so I'm gonna have you answer the rest of the number 4, and let's see if you can answer number 5 as well. And that's it for this worksheet.